Okay, so we'll still continue with the theme of exponentials, okay, and logarithms, but I'm going to give you a slightly different equation that I want you to think about. So have a look at this. We've got 5 to the power of 2x minus 8 times by 5 to the power of x plus 12 equals 0. Okay, so have a look at this. Have you got any thoughts of how we could solve this? I'll give you a hint.
The base is the same.
Base of the powers, yeah, absolutely. So that's the same and that's the same. It's got base 5. Perfect. Anything else you notice? Does it look like an equation which we've looked at before? Yes and no. So no, it doesn't. Like I've never written an equation like this down on the board before. But it does have some of the properties of an equation that we've looked at before. Okay. Have a look at this. Okay. We've got 3 terms. 1, 2, 3. Well, 4 terms if we include the 0. Okay. And it's all equal to 0. And have a look. We've got a constant term. We've got something multiplied by, well, okay, we've got 5 to the power of x. And we've just got something where this power is double this power. Okay, so have a look at that. So the power of this first term is double the power of that middle term. Yeah? Now, that kind of property where we've got 3 terms, constant term, and then the powers, so this power is double this power, that kind of follows the same sort of spirit, the same kind of, the same kind of idea as a quadratic, doesn't it? So for example, if I write down x squared plus 3x plus 4, for example, okay, in fact, minus 4, let's say, right? You notice that the power of the x in this term, this power, is just 1. And this power is 2. So the idea of a quadratic is that it's kind of set up like this. So you've got some term with a power in, another term with a power in, where the power of this first term is double the power of that second term, and just some constant equals 0. That's kind of what we've got going on here, isn't it? Kind of. Because look, that power is double that power. So we call this a hidden quadratic. And I know we have looked at this before, but perhaps not in this kind of context. So it's called a hidden quadratic. So the idea is there is kind of the properties of a quadratic going on, in the sense that that power is double that power, and we've got 3 terms equal 0, okay? Follows the same kind of properties, the same kind of idea as an ordinary quadratic. So okay, just to make it a little bit more obvious, if we say 5 to the power of x, would you be happy that we could write 5 to the power of 2x as 5 to the power of x all squared? So let me show you what I mean. We could write this as 5 to the power of x all squared. That's my 5 to the power of 2x. Does that make sense? In which case I get 8 minus 8 times by 5 to the power of x plus 12 equals 0. So you're happy that thing is the same as that thing. Does that clear things up? Is there anything that I could do here? So this is looking a little bit more like this, because look, I've got something squared minus 8 times something plus 12 equals 0. That's similar to what I've got going on here. What about if I well, just to make it a little bit clearer, let's let u equal 5 to the power of x. I'm just letting a new variable, I'm introducing a dummy variable, and I'm letting it equal 5 to the power of x. So in that case, my 5 to the power of x there just becomes, well, u squared, perfect, minus, yep. Exactly, I'm just replacing 5 to the power of x with u. That looks so much like a quadratic now. Does that make sense? Okay. So, how would I solve this quadratic then? Good. So negative 8, don't you mean? Yeah. Yep. Can you think of any? 2 and 6. Negative 2 and negative 6. Perfect. So because it's a straightforward mnemonic quadratic, I can just factorise it to u minus 2, u minus 6 equals 0. In which case, that thing can equal 0, which means that u equals 2, or that thing can equal 0, which means that u equals 6. Okay. Now obviously I don't want u. I said u is 5 to the power of x, so I'll make my substitution back now. So 5 to the power of x equals 2, or 5 to the power of x equals 6. Okay, so how am I going to find x from this first thing, the 5 to the power of x equals 2?
Is that the square root?
It's not square root. Remember that I'm after the power, aren't I? So how do I find the power? What do I use?
Log.
There you go. So it's log to the base 5 of 2. And just while we're at it, this one would be x equals log to the base 5 of 6. So yeah, just stick those in your calculator for me. And can you give me your answers to 2 decimal places? Is this one, the log to base 5 of 2?
Yeah.
0.43.
For the 6, it's 1.11.
1.11. Perfect, well done. Is that okay? Yeah. So really this kind of looks more complicated, but it's really not. It's just another quadratic, yeah?